Bonjour à tous. Donc c'est la deuxième session IPv6. I have to inform you that the first part of this session will be held in English. I'm sorry for my very bad English using a typical French accent. First, I would like to welcome our two Czech colleagues from Brno University. Thomas Podamansky will be the speaker. He works as a broken network administrator, research developer, and PhD student at Brno University of Technology. Participates in several research projects focused on security, monitoring, and IPv6. Professional experiences, shares as an active member of a European project in the activity Gen3, campus-based practice. And Matej Dweg, which is the co-author, PhD student at Brno University of Technology, teach network-related courses and in research concern IPv6 security, monitoring, and deployment. Works also as a network administrator at Brno U Campus Network and participates in the European project Gen3 campus-based practice. So, Thomas.
Thanks for introduction. Before I start my speech, I'd like to ask you how many people sitting in this room is running IPv6 in their network? Please, hands up. Oh, a lot of people. And to opposite question, how many people is not running IPv6 in this network? Oh, much more, so it might be interesting. So, in this, doesn't work. So, we saw some technical issues. So, in my speech, I'd like to say a few words and share with you our experience with deploying IPv6 at the university campus network, and point out several troubles that we've been face it with. So, at the first slide, let me introduce you a little bit our Czech network research network. That is a network that connects all universities in Czech Republic, including research institutions, and all universities are members on this research network. This research network, in technical point of view, are based on WDM technology and MPLS technology. One of the members of this research network is Brno University of Technology, is the one of the biggest university in the Czech Republic, sitting in the second biggest city in Czech Republic. There is about 20,000 students and 2,000 employees, and university have about 9 faculties and several organization units. From the network point of view, very interesting area is a students' dormitory, where we have 6,000 students connected over 100 megabit and 1 gigabit links, and it's a very nice and good environment for any kind of testing. So we use it very often. From the problem of the university is that the university is not located in the one place. So we have several campuses, more than 16 campuses placed in the different place of the city, and each campus is a sub-campus is connected via 2 independent links from 2 directions, and this map shows a layered 3 topology of the network. The network is based on Hewlett-Packard devices, and on this picture you can see only core of the network, and this network connects individual sub-campuses over 10 gigabits Ethernet lines. Basic routing protocols is OSPF version 3 for IPv6, and external connectivity is provided over 2 10 gigabit lines to a national research network over 10 gigabit lines. Related to IPv6, we start first steps in 2002, when we established first IPv6 connectivity over tunnels, and then we start working on IPv6 activities and our network. By this time, we run completely separate environment for IPv4 and IPv6 network, because IPv6 network was kind of experiment, and we wanted to minimize impact on the running IPv4 services. So we used completely divided infrastructure, including routers, servers, paths, etc., etc. The significant change became in 2010, when university was involved in Hewlett-Packard beta testing program, when we start working on firmware with cooperation with Hewlett-Packard that supports IPv6 in their devices. So we were involved in this program, and based on this result, we decided to move this experimental network to fully production environment by removing this experimental network and start operating in complete dual stack on the basic network. So at the end of 2010, we have finished this move to dual stack environment, and we also had some experiences with renumbering network, because we wanted to start using provider-independent address on the campus network, because also in IPv4 environment we have our provider-independent address. We wanted to have just the same address for IPv6. And after this, we were able to move important services at the university to dual stack environment, and it's quite obvious that many services, it's quite easy to move to IPv6. You just switch on it on servers, and it just works. But there are some about 10% of services that is very difficult to move to IPv6 due to lack of support on the software, etc., etc. So now I like to point out several problems. I think the biggest problems with IPv6 that we have been faced with at the university environment. One of the biggest problems is auto-configuration. Auto-configuration in IPv6 have been meant as the simplification of auto-configuration that we have in IPv4. Just put cable to the network and you have everything to run IPv6. But in reality, it doesn't look so well. IPv6 brings complete new idea of auto-configuration based on stateless auto-configuration, where router periodically advertises to the network own address and own prefix, and clients configure their own IP address based on their decision. But problem with this technique was that this technique doesn't contain address of recursive name servers, but we need name servers to communicate over network. So it's one of the biggest problem of this technique. From the opposite side, IPv6 also introduced the DHCP version 6 protocols, but these protocols have another problem. This protocol doesn't contain the address of default route. So in reality, we have to run both mechanisms in the network, and both mechanisms that shares completely the opposite idea. One is centralized, the DHCP server, and one is kind of freedom mechanism that computers creates own address. And these complete opposite ideas we have to run into one network, in one computers, and this brings many troubles. So there is problem with securing both of them, and what's worse, different platforms support different auto-configuration techniques. So Windows XP supports only stateless auto-configuration. Almost all operating systems support stateless auto-configuration. Only few systems support DHCP v6. So it's quite a problem. To illustrate this problem, I take some communication over Ethereal And what we had in IPv4. In IPv4 before, the node has been able to communicate what are these green lines, this established TCP communication to web server. We had quite easy process. 4 packets with DHCP communication, request, offer, and acknowledge. Then we exchanged some ARP packets. We were able to communicate. In IPv6, it's much more difficult. We have 5 different protocols that all have to run to establish proper IPv6 connectivity. And if one of this mechanism of this protocol fails, user don't have proper IPv6 connectivity. And another problem with IPv6 is privacy extension. We can, the general idea of IPv6 was dividing the address to network part and host part, and the host part was initially created based on MAC address in the computer. But there was a problem, this address was very easily trackable all over the internet, so there was introduced a privacy extension. That means that every node changes own IP address periodically and use more IP addresses in one time. So this is example of regular computer in the network using stateless auto configuration that use 6 or 7 IP addresses in one time. So there is example how this computer communicates in time, and we can see in different time slots this computer uses different IP address. Another problem very little tied to auto configuration process is first hop security. As we said, the auto configuration process is very, very sensitive to any kind of attacks, and can be destroyed very easy. Not only by attackers, but sometimes it happens by improperly configured operating system. This chart shows number of fake router advertisers that we observed in the network. And these fake router advertisers are caused by regularly configured internet sharing service in Windows computer. This is regular usage of these services, but it reaches about 25 computers acts as a router for the network. That means that other clients think, oh, there is a router in the network and we will use them as the default router. And it's a problem. It's just the same situation as running the DHCP server in IPv4 network. There is another problem known more than a year with router advertisers. There is a simple command that creates flood or router advertisers that cause that all Windows computer will freeze at this time. You won't able to use this computer anymore. You have to reboot this computer and start again. This problem is known for more than a year in a Microsoft system. Not only Microsoft system, more systems are affected by this trouble, but is not solved yet. Is at the border of the interest of producers. So possibilities to solve this problem. In IPv4 world, as we said, we have quite easy situation because IPv4 auto configuration means DHCP. And we know techniques how to protect against fake DHCP server at the IPv4 environment. The easiest one is DHCP snooping, and this work very easy, just blocks answers from the DHCP server on the user's access ports, so quite easy protection, and it works very well. Another level of this protection is dynamic ARP protection or ARP inspection. Different vendors cause in different names, and it's another level of protection when we learn database MAC address and IP address, and then we do some inspection of ARP packets in the communication between a host and router, for example. And the strongest level of this inspection, we just use the same database on the switch and check all packets, and this kind prevent us against source address spoofing. So that means in IPv4, we know some mechanism how to protect against this kind of attacks. But in IPv6 was much more difficult. First solution proposed is secure network discovery. It's technique announced by Cisco, and the idea is of crypting these neighbor discovery packets and router advertisers packets by crypto mechanism. But the problem of this technique is that it requires public key infrastructure. That means you will have to have certificates on all computers, on all routers, and you also will have to replace these certificates on routers periodically, for example, every 2, every 3 years. So it's a little bit problem to use in a real network. Another problem of this technique, there is no existing implementation of this. There are only some experimental implementation for Linux, and on the server side, this SAND is supported only in Cisco devices. Another problem of this technique that supports only address created, but this algorithm is not possible to secure by this way manually configured address or address based on privacy extension. Another level of security is router advertisement guard that protects our network only against fake routers. And this is the feature that is available on some Cisco switches. And this techniques only protects against fake router advertisement messages, not protect us against fake DHCP v6 messages. So it's only partially solving of the problem. And another proposed is SAVI. It's source address validation improvement. I think it's full name of this technique. And it's several of drafts and divided into different parts and try to solve this problem in a complex way. And this technique is usually available on Huawei switches. But it doesn't solve our problem. There is another problem. There are actually no switches on the market that support these features for IPv6. We have a lot of switches that support these techniques for IPv4, but there are no switches on market that supports just the same thing for IPv6. And what worse, there was a find way to bypass this protection mechanism by some guy from German. And there is a simple script in Scapy that is a library for Python that you can create your own packets very easily that bypasses all these mechanisms. So even you have perfectly secure network for IPv6, you don't have secured this network for IPv6, for IPv4 I meant before. So there is a problem, and the right solution doesn't exist yet. Another problem is monitoring and accounting. As I said, privacy extension brings new idea of addressing, so every host has several IP addresses, and it's quite difficult to make some accounting or some analysis, for example, behavioral analysis on the net flow data if this addresses changes, because all these techniques are based on the stable addresses. So there is an example, if you want to filter traffic for the one host, you have created this complicated filter where you put all these addresses, and you also solve the opposite problem. You know IP address, and you want to know who was using this address. We tried to find a solution with our own system that we created at the university. It's based, I only briefly will talk about it. It's based on the NetFlow, where we try to extend basic NetFlow data with some other items, generally by MAC address, where we can find a relation between MAC address and IPv6 address in a neighbor cache or ARP table on the routers, and we have to obtain this data in some different way. And if we have this data, we also can extend this NetFlow record by information about switch port where was the user connected. So it's quite good to use because you have IP address, and you can directly in network data can see which switch port has been used. And another level of this represents if you use, for example, X authentication of if you have any kind of database with authentication data, you can join it together with through MAC address, for example, from radio server, and you can have directly in NetFlow data related to particular user. Then you can make some behavioral analysis, you can make a top-end statistic, etc., etc. Only briefly, when we can get particular information, mapping between IPv6, IPv4 address and MAC address, we can obtain from router neighbor cache or ARP table, so we can have to periodically pooling records on the router and save into database and then to combine it, then to put it together. Or we can put some probes into every network segment, but it's a little bit problematic. If you have 200 network segments, you are not able to put this probe to every of them. Mapping between MAC address and switch port is quite easy. It's based on the switch database, so that means you have to download forwarding database from all switches that you have in the network. So it's a little bit complicated because you have to have manageable switches and you have to have access to all these switches. And there are some results how this system can be used. At the first tab, we raped MPLS flags to use for user identities, so we didn't want to extend the system so much, but now we are working to have separate items for user ID and other items. And this ugly output shows how the filter for one user can look like. So there is at the top of the line there is a filtration rule for one user, and then we can see that this user uses many other addresses, including IPv4 address, IPv6 address in one list, and we can do anything what we want with these items. Another problem of IPv6, rather political, not technical problem, is impact on existing IPv4 infrastructure. As usual, if you deploy something new into network, that means that have impact on this stability of the network. You have to upgrade routers. You sometimes have to change firmware, and code of the IPv6 in the routers and switches is brand new. So there is a lot of bugs. So you have to upgrade this firmware more often, and you have to have very, very good relationship between your supplier and your IT staff, because you have to really participate of debugging this software. Yeah. And it costs extra effort. And what people very often forget that IPv6 another way how to reach the nodes in the network. They usually start using IPv6, configure it on the interfaces, and they usually forgot to configure firewall and IDS system and other systems that they have for IPv4, they don't use for IPv6. It's not a problem today because we have very, very small amount of IPv6 traffic, but it's potential danger. So you have to remember about it. And what's the biggest problem of the IPv6? Users and as well as managers who pay for it usually don't understand why we do this IPv6 stuff, and they ask, why is the network less stable than before, and what are the benefits of IPv6? We can't understand that. And this put us into very, very difficult position, because it's quite difficult to describe what benefits IPv6 brings immediately. So there is a quite big political problem, and I actually don't know how to solve it. Another problem is that IPv6 and IPv4 are incompatible protocols. So if you have at least one application that doesn't support IPv6 at the network, you still have to run both protocols. And it doesn't matter if it's kind of translation, NAT64 and DNS64, or you have to deploy a regular NAT on IPv4, because for this application needs it. And unfortunately, most of application today doesn't support IPv6, including this most interesting application for user like Skype, ICQ, Microsoft Messenger, etc. This application doesn't work on IPv6 environment, so you have to run IPv4 as well in IPv6 network. So I showed a few problems that we've been faced with in the network. So there are, of course, some other problems, but I try to point out the biggest problems that we feel that are in IPv6. And I prepared some statistics obtained from the university network. The first statistic that shows number of traffic comparing IPv4 and IPv6. This chart shows total number of traffic, and if somebody tries to find the IPv6 traffic is here at the bottom, so very low number. This is just the same traffic in the separate chart, but we can see there are some peaks that reaches 200 or 300 megabits of traffic. So it's not too much, but it's not so little. 200 megabits is quite good traffic. But the amount of traffic usually doesn't say nothing, because with this computer I'm able today gonna create, for example, 500 megabit traffic. So it's something else to measure that is more interesting. The number of addresses that the university campus was talking with. This chart shows how many unique IP addresses around the world we were talking in 1 hour. And we can see that this number reaches 300,000 unique IP addresses for IPv4. In IPv6, not much. It's about 10,000 unique IPv6 numbers. So does it mean that there is no content on IPv6? So there is another problem, and it's a really big difference comparing this number previous and this number for IPv6. What we can conclude from this? We can say, oh, IPv6 is here, but nobody uses it, we don't need it, and it's not our problem. We can just wait, and wait. But this chart shows something completely different. The bottom line at this chart shows number of hosts using IPv4 address. It means that this number of hosts that has at least one IPv4 address, and we can consider this line as total number of hosts in the network, because we don't have any IPv6 only hosts at the network. And the bottom line show number of hosts using at least one IPv6 address. And we can see 89% of clients today in the network supports IPv6. So it doesn't matter if you deploy IPv6 today or not. IPv6 is here, is today on your network, even you not deploy it. And this network is vulnerable by all these problems that I showed you. That are also some other problems. So it's easier to deploy IPv6 into your network than have completely unattended IPv6 environment in your network. What we can do about this state? I think the one big thing is start using IPv6 immediately. We have been waiting for perfect IPv6 for very, very, very long time. Today is more than 15, maybe 16 years, and we see it doesn't work. IPv6 have to be used by people, by handy people who will provide feedback to creators of the standard that, guys, no, this way is okay. We don't want to use this protocol in that way. Another point, prefer IPv6 native connectivity. IPv6 is not perfect today, but controlled connectivity over IPv6 is much better than completely unattended traffic in your network via tunnels or anything else. Ask vendors and creators of the standards to fix problems. In many cases, the vendors will completely ignore you and say, oh, we have in to-do list, but it's not time today to solve it. But more requests will escalate these troubles, and they will probably start to solve these problems. And I think one of the biggest point is, especially for people who try to deploy IPv6 and show IPv6 only in the nice light, stop pretending that IPv6 have any troubles. IPv6 actually have a lot of troubles, and we cannot continue with covering these troubles at all. We can say, this is trouble, this is problem, we have to fix it. Until we change this attitude to IPv6, things will never change. Okay, that's all my presentation.
Thank you, Thomas. Thank you very much. If you have question, please ask your question in English. I will not be able to translate all the sentences. Thank you, Stefan, no? Yeah, I'm sure you have questions.
Hello, Stefan Bartsmeyer from APNIC. When you talked about privacy extension, you said that it's not possible to account the number of bytes sent by a machine. It seems to me not a bug, but a feature. If people are using privacy extensions, it's not to be tracked. So if it were possible to account for the bytes transmitted by people with privacy extension, it means you would have discovered a big security bug.
Yeah. I think I completely agree with you that that is a feature, and it was mentioned in that way. But in some application, we have trouble with that. And if we start using IPv6, we have to deploy some other techniques and some other mechanism how to solve this problem, especially at the local network. But I agree with you, this is the feature, and it requires a little bit different point of view to how we look at the problem. But it's sometimes I feel that is a problem in some operators' network, because this looking on the problem from the different way costs them money, and they don't want to spend money for this different point of view.
It simply means that the interests of the users and of the operators are not aligned, which is not a discovery.
On voit pas grand-chose avec les spots dans les yeux. Vas-y, continue, ne jette pas.
Another one, if I'm the only one. When you were, I was a bit surprised by your slide about send, because you talked about the difficulty to get its own certificate for a client, about the fact that it doesn't work with manual addresses or privacy extensions. I'm not a big expert in send, but it seems to me that it's not true. With send, you don't need a certificate for each client. You authentify the router, not the client. So you only need in the client a certificate of the certificate authority that signed the router. So you don't need one certificate per client, otherwise send would be even worse than it is.
Yeah, right, but you have to have root certificates on the clients to find the path to certificate that was signed used by the router. So you have to know this certification path. If you have root certificates on your clients, that's okay, but it's not case for all devices, including printers, cameras, etc. They don't have this certificate, so it's a little bit problem. It's quite easy task on the computer, because we have good environment for that on the computer, but these small devices have a problem with that. And there is another problem with send. If you want to have some certificate that is pre-installed in operating system, you usually have to buy this certificate in some company. And I don't know if operators would like to buy certificates for router because it costs money, of course.
No, I agree that send is extremely complicated and actually nobody is using it except maybe for a few military environments. But it doesn't require its own certificate per client, and it works with privacy extension because send only secures retrieval of the prefix. Once you have the prefix, you can put what you want after it.
We are talking about a situation when we secure our neighbor discovery process, and in this case, we have to use this address created by this CGA algorithm. So. But there is possibility that there is a way for send in future. I think it's not a bad idea. I think it's quite good idea because we don't have to secure intermediate infrastructure, but it's not possible to use it today because lack of implementation. So it's not solution for today, maybe for future.
Thank you, Stéphane. There is another question. Il y a une question juste derrière, s'il vous plaît. Merci.
Hi, I am Bertrand Bourchanin from network of the campus de la Doua, Villeurbanne, Lyon. I don't know very much privacy extensions for IPv6, and I'd like to know as monitoring, how can I monitor people who decide to do privacy extensions? Can I try to make so that they can't use this sort of feature? Do you get what I mean? Can I avoid people from using privacy extensions so that I can be sure to monitor?
Yeah, I understand what are you asking for. There is a big trouble in that. There is two ways. Either you use stateless auto configuration, and that means that you automatically, on some operating system, because it depends on operating system, whether it use privacy extension or not, and it automatically, in many cases, start using privacy extension. The only way how to prevent this privacy extension today is enabling DHCP server, or what you can say in messages, router advertised messages, and stop creating on address based on stateless auto configuration. But this means the address have to be obtained from DHCP server, and in this case, only clients that supports DHCP version 6 will be able to communicate over v6 environment. That means that some older operating system either they have IPv6 stacks, they won't have any IPv6 address. And there was, I think, 1 year ago, big discussion in ITF about flag that will show to the client whether this privacy extension should be used or not, but this idea was destroyed.
Another question? No more question. So thank you, Thomas. Thank you very much.
Thank you for your attention.